I am excited to introduce our next speaker and to hear his talk. As people know me, I love using analogies to try to describe everything, sometimes good, sometimes not so good. And I've known Niki since kind of his first startup. He's one of the most creative and entrepreneurial people that I know. So really excited to hear Niki talk about the latest work and research he's doing about using analogies to innovate. So with that, Niki Kittur.
All right, well, let me get started. As you can see, I don't actually need slides, right? I can do this because part of the problem we're dealing with is innovation. So how do we handle the challenge of innovation? How do we do creative problem solving when things go wrong? How do we adapt to that and move on and come up with creative solutions to that? And that's becoming a bigger problem than ever before. We're spending more money on innovation and we're getting less for it than we ever have before. That's not just a perception, and it is a perception that a lot of CEOs share. About 6% think that innovation is going well for them at their companies. But there's a lot of research as well showing that innovation is actually decreasing, disruptiveness is decreasing. There was a really nice paper in Nature recently showing that no matter what field you're looking at, whether you're looking at papers or whether you're looking at patents, innovation disruptiveness is actually decreasing over time. And you can just look around you, right? Like look around at the cars on the street, at the devices in your pockets. We're seeing a lot of homogeneity. And the question that my group looks at is, how do we accelerate truly disruptive innovation? And this is work that's really not just me. I get to be up here talking about my great students' work, about our collaborators at Toyota, AI2, Microsoft, Facebook. A lot of people are going to be responsible for what you're about to see here. Okay, so I mentioned how difficult innovation is today and how that is getting worse. What's the solution to that? As Jim pointed out, over the last 10,000 years of history, the solution has been analogies, taking ideas from distant domains and applying them to the problem you're trying to solve. This is not new. Chrysippus looked at a rock falling in a pond and said, hey, wait, those pebbles, those ripples look like maybe we can explain sound waves that way. And they've driven a lot of innovations in products and technology. The Wright brothers looked at an inner tube box and said, hey, the way this thing shears, maybe we can control our wings in a very lightweight way and steer our plane this way. The vacuum you might have in your home, the Dyson vacuum, is actually Dyson came up with that idea from a sawmill that he was working in, where the sawdust was getting sucked out by a cyclone that he tried to miniaturize and put in a vacuum. So how do we accelerate this type of analogical innovation? Turns out to be very challenging to do that. And if we sort of naively use the ways that AI is deployed today, we actually risk doing the opposite. We risk lowering our creative breakthroughs. And there's, again, a lot of evidence about this. Using AI leads to less critical thinking. I organized a workshop with Microsoft about tools for thought and how this is having really deep repercussions on our workforce. It's leading to homogenization. Those great ideas you think that it's giving you, guess what? It's giving them to everyone else too, right? And it turns out there's mode collapse. After you have a certain number of these, the rest of them look pretty much the same as the first ones that you got. And they're promoting it's a very linear interaction, a very linear way of thinking that we tend to have with these tools, mostly because of the way that our interfaces are designed around conversation rather than the nonlinear ways that we think when we're being creative. So I'm going to talk about our lab's work on how do we actually use AI to accelerate analogical breakthroughs. There's a lot to cover. I'm going to just give you an intuition, but if you want to be smart, you can search at scale, map, those ideas to the target domain, adapt with actual human expertise, refine and iterate on your ideas, and test them for viability. So let me show you a little bit of what we're working on. Okay, so let's first talk about searching. Analogical search is actually much harder than the kinds of search you would do on Google because you're not searching for keywords, you're searching for concepts, you're searching for abstractions. How do you do that? How do you search when the keyword associations that drive most of our search engines, most of our AI is actually the opposite of what you're trying to do, right? You're trying to find things that are from diverse domains, not things that co-occur together. And this is actually not just a challenge for machines. Our memories are also set up with a surface-based bias. And what that means is it's very hard for us to find analogies even in our own heads. And the more expert you become, the harder that is as you become fixated on the area of your expertise. So how do we solve that? We actually introduced this new idea called purpose mechanism schemas. The intuition here is that you can take any product or idea and break it down into two things. What's its purpose? The purpose of this is making yogurt. It's a yogurt making machine, very simple, right? What's its mechanism? It does that by using this vacuum-cooled drum. So we can learn these at scale to separate them into two different embedding spaces. We can learn two different vectors from the same description, and we can do that at scale with a bunch of products. And then what we end up with is actually a really interesting representation that allows us to take the same purpose and find things that are really different in terms of the mechanism space, okay? So let's say that you have a cell phone charger case. If I was to use, say, Google to search for things, it's gonna give me other cell phone charger cases, right? If I just give you random ideas like shampoo pods or dog meetup apps, that's not really gonna help you. They're not structurally aligned with what you're trying to accomplish. By using this purpose mechanism approach, we can find things like a human pulley-powered generator suit, right? Which was one of my favorites that came out of that. And you might not use this directly, but you might say, okay, maybe I can put piezoelectrics in my shoes, or I can harness the walking motion of my arms to be able to leverage this problem space of the idea. And it turns out that when we give people these ideas, they are more than twice as likely to generate good ideas as rated by experts than giving them the other solutions. So there is something here to being able to computationally scale up the creativity of people by giving them access to analogical ideas. Now, the problem is that just giving people ideas isn't enough, right? It's very hard also to see an idea and say, how am I going to use that idea? So let me give you an idea here. Here is a snail. It secretes mucus from its foot and uses it to move around and to stick to things. How will you design a better bike rack for your car with this? Any ideas? It's kind of hard, right? What are you going to do with this snail, right? I asked an LLM, how would you do this? And it came up with this. I don't think it's great. I think we can improve on that. So we designed a system called BioSpark. This came out and was a best paper honorable mention at Chi 2025, just a few months ago. The basic idea behind BioSpark, I'm not going to show you everything, is that we can take inspirations like the snail mucus and cluster them and show them to you, but we don't stop there. We actually transfer those inspirations to the domain that you're interested in. So I'm sorry, this is a little hard to see, but on the right you see a bunch of cards. Those cards are telling the user, how could you actually use this? You can use this, the top card is looking at how you can use this for, let me try to play this. How do you use this for a bike rack? Well, you can actually use the mucus to adapt to different sized bikes. And you can, the second one is sort of using the way that it sticks to things and moves around as sort of a muscular arm for doing things. And it doesn't stop there, right? So we can actually have the user interact with this to ask, well, can you use that? Like, I'm not going to use actual snail mucus. Like, what am I going to actually use? And it'll say, oh, you can use hydrogels, and here's 3 different types, and these ones are not brittle under winter conditions, right? So we're trying to help people not just take an idea, but transfer it to the domain and map it and try to figure out if they can use it. And what we found when we used this with real designers and advanced PhD students is that people preferred this to using ChatGPT. They found deeper engagement in actually thinking through the ideas, like, hey, maybe I can use this idea of retracting limbs, and it makes me think of like a slot mechanism for wheelchair wheels. And we looked at the ideas. They considered many more ideas. They explored a wider design space, and their ideas were more creative than if they used ChatGPT alone. So what we're seeing from this is that it's very important to not stop at just providing ideas. We need to help people understand how to use and think through those ideas. And that continues when we think about human expertise. We don't solve really important, impactful problems by just taking something wholesale. Think about the example of the Wright brothers. They took this cardboard box. They didn't make their plane out of cardboard boxes, right? They didn't even make the wings have kind of flaps that go vertically either. In fact, they use their expertise as mechanics, as avid bicyclers, to design pulley systems to actually transfer and use that same principle of shear was actually transferred through a pulley system. So human experts don't adopt inspirations wholesale, they adapt them. And this is what makes human expertise so important, is that we just have to get people into the right part of the design space and then rely on their expertise to help find and adapt them. So we've applied some of these ideas with real experts. I'm just going to show you a couple examples of how this adaptation works. So one expert we worked with was looking at how do you reduce computer chips from overheating. And when we gave them a regular search interface, they found things like here's this metallic thing that conducts heat better. And what they did was they just used it directly. They're like, yeah, okay, all right, maybe I can use this. I kind of know about stuff similar to it, but yeah, all right, I can directly use that. When we gave them analogical ideas from the types of systems I was showing you, they creatively adapted those ideas. So we gave them, for example, a fin structure, and they were like, I mean, like fins, I can't use those at the nanoscale level. Well, hold on, maybe I could. What would a nanoscale fin for turning heat into motion look like? Actually, that's kind of interesting, right? And so we found that across the board, experts were not taking ideas wholesale from what we were giving them, but creatively adapting them, from a thin film evaporation idea to manipulating how hydrophobic the material was, from a nanoparticle fertilizer to saying, interesting, I actually see the way that they are measuring the nanoparticles, which is more interesting to me, which is around hyperspectral 3D imaging. So how do we help people bringing human expertise into the loop? And it's not just giving people ideas. We've also looked at giving people other experts from different domains. So we worked with a company called Conservation X Labs. They put on conservation challenges as innovation challenges and contests. And they came to us and said, oh, the ideas we're getting are just not that novel, not that interesting. What can we do? And we said, why don't we try matching people who don't win at one stage of the contest with the teams that do win at the next stage of the contest, but find people from different areas. So for example, we could match up people who were trying to remove microplastics from the ocean. We might match up a person who uses drones for finding poachers in Africa, and they can use the types of computer vision algorithms for identifying poachers, for identifying kind of where there are and what types of microplastics are in the ocean. And what we find from doing this, the first time we ran this, and we've run this over half a dozen times, over $2 million is being allocated in prizes, in real contests using this. The first time we did this, we actually got the reverse of what we wanted. We actually got worse ideas when we matched up experts. And it turns out that that's because if you match up experts that are too far apart from each other, they don't really know how to talk to each other. And they spend too much time trying to figure that out than being useful to each other. So and the reason we found this out is we ran this as a controlled experiment where half the teams got our intervention and the other half didn't. So since then, we've found ways to match people who have complementary expertise, who are very different on the surface, but share kind of a common underlying structure to the problems they're trying to solve. And we've seen significant improvements in novelty and usefulness of these ideas. Okay, refining and iterating. What I've shown you so far has felt kind of like one-shot solutions, but that's not how things work in the real world. We might think of innovation as kind of a lightning strike, but in reality, there's so many branches of paths that you have to explore and evaluate to get to the one that is the most valuable. So how many iterations do you think it took Dyson to go from this idea of a sawmill vacuum to a vacuum that you see in your house? The first iteration, like the first real vacuum. How many iterations? Any guesses? 10, 200, 5,000. Took him 5,000 iterations and prototypes to get to the kind of vacuum you're seeing. And that's because there's so many problems. There's sub-problems when you solve the big problem. You might start with you might start with the problem of this industrial cyclone. That's great, but how do you scale it down? And well, yeah, I can use a tangential inlet, but that's not very efficient. So now what do you do, right? And this just keeps going down. It branches and branches and branches. So how do we help people not just with one-shot solutions, but going through the whole process of exploring all of the different paths and ideas so they don't get stuck at the first time they run into a problem? So we developed a system called FlexMind, and in the, I don't know if we can play this. Okay, so I'll show you. Like in the short version of this, and just to save on time, is that FlexMind worked really well. It seems to improve idea quality. Now, how does it actually do that? And here's the intuition. On the right, you see ChatGPT. It's a very linear interface, right? You say, hey, give me some ideas. I get a bunch of ideas. And it's kind of hard to go back and forth to explore multiple ideas. What FlexMind does on the left is it shows a canvas of all of your ideas, and the AI helps you to explore, you know what, yeah, it is hard to miniaturize that thing. Here's some ideas on how to solve that. Oh yeah, well we can, there are some problems with going down that path. Here's some other solutions that you can take. And so what you can see on the bottom is ChatGPT shows a bunch of solutions, which are in blue, the little blue circles, and people only follow up on one or two, whereas in FlexMind, people tend to explore many more solutions in much more depth. And here's the same people using FlexMind on top and ChatGPT on the bottom. You can see that they explore their ideas much more deeply with deeper trees of ideas than they do in ChatGPT alone. And it turns out that deeper exploration does statistically significantly lead to better quality ideas. Ideas from deeper down in the chain are rated by experts like the head of we had a head of an R&D for a major consumer appliance company rate these. These are kind of as real as we can get to real ratings. Our deeper ideas lead to better quality ideas. Okay. All right, then the final thing I want to talk about is testing viability. So it's not enough to simply go down all of these different paths. Like, that's overwhelming to people, right? There's so many paths you can go down. We need to help people with figuring out which paths we can prune and which paths we can go down further. So we developed a system, and this is something that's very much in active development, and we're looking to partner with people to think about this, to help people with deciding which paths to go down and the viability of those paths. So imagine you're trying to, this is actually an open problem for Procter & Gamble around novel ways to floss without using a flosser. And what our system does, and I'm just going to play this. I'm going to play this video. So what you can see here is that we can not only come up with ideas, but work through those ideas too. So we can generate an idea here. It's around magnetically assembled soft auger rinses. So you got little particles, and there's like a mouthpiece that circulates these things in a way that's safe, but also removes the plaque without you having to go in and do all these things. And the system is itself generating the concepts. It's telling you about the active ingredients. How does this thing actually work? Where do they come from? It's looking at the outcomes of what this would do, like what percentage improvement would you get from using this? Safety, biocompatibility. Where is this thing used? Is it used in other dental places? Is it used in non-dental places? Yeah, maybe you'll have some more viability if it's actually used somewhere that's outside of your domain. We look at impact readiness levels. Can we try to figure out what the landscape of the different options here might look like, and how close they would be to commercializability? We look at what might de-risking this look like if you needed to run some MVPs and experiments, and how much would that cost? We look at what partners that you might want to work with when you come to the idea of who should help me, who's got the expertise to work on this. So innovation is much more, as I'm sure all of you know, innovation is much more than coming up with an idea. It's about taking those ideas, working through those ideas, and trying to map them to new domains, explore what actually makes sense, refine and iterate on those, incorporate human expertise, and do this for so many paths. There's so many pathways that we need to explore to be able to actually do this well. And what we're looking at is, how can AI, we have at least some proof points now that AI can help with doing all of those steps. So what we're looking at, and I would love to talk more with anybody who's interested, is how do we, who's interested, who cares about this? We're looking now to work with some companies to validate this in real world situations, to surface and validate thousands of non-obvious ideas from both within your company as well as outside of your company to accelerate your next breakthroughs. If you'd like to discuss more, send me an email or catch me at the reception. Thanks very much.